A commander wants coverage over the Pacific. The task sounds simple inside the briefing room. Get more imagery, move data faster, add communications capacity, push analytics to the edge, shorten the chain between a sensor and a decision. Then the staff starts asking what sits underneath that request. The imagery comes from a commercial constellation whose satellites include foreign-sourced components. The data rides through a ground network with leased sites in multiple countries. The analytics run through a vendor cloud stack. The launch schedule depends on range access, booster availability, weather, propellant, and one supplier that makes a sensor package everyone quietly assumes will arrive on time. The company has venture investors who care about quarterly burn rate. Its best engineers are also supporting civil customers, allied contracts, and 3 internal product lines with names that sound like mountain bikes. The commander does not want a seminar, he wants capability. That is the tension. Commercial space gives the United States speed, scale, software talent, and a faster path to new mission sets. It can add capacity in satellite communications, remote sensing, data transport, missile warning support, space domain awareness, weather, navigation augmentation, launch, and ground systems. The Pentagon sees this clearly. The Space Force sees it clearly. U.S. Space Command sees it clearly. Anyone who has watched commercial constellations change the character of war in Ukraine sees it clearly. But speed has a shadow. When the military buys commercial space capability, it also inherits commercial supply chains, investor pressure, foreign market exposure, subcontractor risk, software dependencies, launch bottlenecks, licensing issues, cyber exposure, and the uncomfortable fact that private firms are built to survive markets, not necessarily wars. That does not make commercial space a bad bet. It makes it a strategic bet. Those are different creatures. One sits politely in the acquisition office, the other eats from the national security bowl. This episode is about the vendor dependency trap. It is the danger that the Pentagon treats commercial space as an easy shortcut around slow acquisition, only to discover during crisis that the shortcut runs through fragile supply chains, limited suppliers, contested infrastructure, and business incentives that do not automatically match wartime need. The answer is not retreat into old government-only systems. That road has its own graveyard of delays, cost growth, and exquisite satellites that arrive late enough to qualify as historical reenactments. The answer is disciplined dependence. Buy from industry. Integrate commercial systems before crisis. Map the vendor base. Secure the data paths. Understand the business model. Know the suppliers behind the suppliers. Build contractual terms for surge, survivability, cyber defense, priority access, and wartime continuity. Commercial space can make the joint force more resilient, but only if dependency is seen before the first shot. Today on Orbital Estimate, commercial space and the vendor dependency trap. Start with the reason this trap exists. The U.S. national security space enterprise spent decades building exquisite systems. These systems were powerful, expensive, and few in number. A major satellite program could take years to design, procure, test, launch, and bring into operation. The result was often a platform of great capability, but also great consequence. If you only have a few crown jewels, each one becomes a strategic hostage to physics, budget, schedule, and adversary targeting. Commercial space changed the mood in the room. Private firms began launching more often, fielding constellations faster, refreshing hardware more quickly, and building services that government customers could buy without owning every piece of the architecture. The lesson was hard to miss. In some mission areas, the commercial sector could move faster than the traditional defense acquisition process. That sentence alone should cause several offices in Washington to reach for antacids. The commercial model offered something the Pentagon badly wanted: capacity at speed. Need satellite communications? Buy service from a provider already building a constellation. Need imagery? Purchase data instead of waiting for a bespoke government satellite. Need analytics? Contract a firm that already processes commercial and open source data. Need launch? Use providers competing for cadence and cost. Need resilient transport? Look to proliferated low Earth orbit architectures instead of placing all hope in a smaller number of high-value nodes. The appeal is obvious. The Joint Force faces a data-hungry operating environment. It needs more sensors, more links, more processing, more responsiveness, and more paths around disruption. Commercial space can help provide those things. Here is the catch. A commercial space service is never only a service, it is a chain. Behind that service sits hardware, software, labor, ground infrastructure, spectrum access, regulatory approval, financing, insurance, launch availability, cloud architecture, customer demand, export controls, and supplier commitments. The warfighter may see an imagery product on a screen. The actual capability depends on a long tail of things that never appear in the commander's update unless something breaks. This is where dependency hides. A government satellite program may be slow, but the government often has more direct visibility into design, mission assurance, security, and lifecycle control. A commercial service may be faster, but the government may see only the front end, the contract, the interface, the performance promise, and the vendor's cheerful slide deck. Somewhere inside that cheerful slide deck lives the sentence everyone should fear: our supply chain is globally optimized. Translated from modern business language, that can mean the critical part comes from a country that may not like you during wartime. The subcontractor is one merger away from disappearing. The software dependency is maintained by 3 people in different time zones, and the company's continuity plan was written during a fire drill. A vendor dependency trap forms when government planners assume commercial capacity equals assured capacity. It does not. Commercial capacity is real capacity under normal or semi-normal conditions. Assured capacity is capability that survives crisis, coercion, disruption, legal pressure, market shock, cyber attack, launch failure, and geopolitical fracture. Those are much harder standards. They also matter more for national security. Think about commercial satellite communications. A military user may rely on a commercial SATCOM provider because it delivers coverage, bandwidth, terminals, and rapid fielding. That service can be a warfighting advantage. It can keep units connected, move intelligence, support distributed operations, and provide alternatives when military systems are saturated or targeted. But what happens when the provider faces cyber intrusion? What happens when adversary jamming increases? What happens when terminals become a signature risk? What happens when the provider serves civil, commercial, allied, and U.S. military customers at the same time? What happens when lawyers, regulators, and executives debate whether support to a conflict zone creates escalation risk? The military user sees communications. The company sees a business, a legal exposure, a shareholder concern, a regulator, a safety question, a reputation problem, and a war. Both views are rational. They are not the same view. This is the core of the trap. Commercial firms can support national security without becoming military units. They can provide essential services without sharing the full risk tolerance of the force. They can be patriotic, competent, and serious, while still operating under market incentives and legal constraints. The Pentagon cannot simply assume that a commercial provider will behave like an organic military asset during crisis. It must define expectations before crisis. It must contract for continuity. It must understand where the company draws lines. It must know what happens under jamming, attack, sanctions, export restrictions, foreign pressure, bankruptcy risk, or capacity conflict. That sounds less thrilling than a launch live stream. It also matters more. The same issue applies to remote sensing. Commercial imagery and analytics can help the joint force understand terrain, infrastructure, maritime movement, missile activity, disaster zones, and battlefield change. The speed and volume can be remarkable, yet a remote sensing firm depends on satellite health, ground station access, data processing pipelines, customer priority rules, cloud resources, licensing, and employee availability. During peacetime, that looks like a product catalog. During conflict, it becomes a contested intelligence supply chain. If a country pressures a ground station host, the service may degrade. If an adversary hacks a processing environment, confidence in the product may fall. If multiple customers demand priority at once, allocation becomes strategic. If licensing rules change, delivery may slow. If satellites are dazzled, jammed, spoofed, targeted, or maneuver constrained, collection plans change. The warfighter wants data. Reality sends a strongly worded memo written in smoke. Commercial launch has its own version. Launch providers give national security space a path to more frequent deployment, constellation replenishment, technology refresh, and resilience after loss. In a future conflict, launch cadence may become as important as satellite design. A force that can replace, replenish, and augment space assets quickly will have an advantage over a force waiting for the next slot on a crowded range. But launch is not a magic elevator. It depends on boosters, engines, avionics, payload processing, range availability, weather, ground crews, propellant, transportation, pad infrastructure, integration timelines, safety approvals, and mission assurance. A launch company may be commercially brilliant and still constrained by a single production bottleneck or a pad outage. One supplier delay can ripple through the manifest. One mishap can close a range. One regulatory fight can bend a schedule. Rockets are honest machines. They refuse to care about PowerPoint urgency. Now move from mission areas to the deeper structure. The vendor dependency trap has 4 layers. The first layer is concentration. Commercial space markets often reward scale. The company that launches frequently gets better at launch. The constellation that reaches size offers better coverage. The data firm with more users improves its tools. The provider with a mature ground network becomes easier to buy from. In theory, this is good. Scale lowers costs and improves service. In national security terms, concentration can create a narrow dependency. If 1 or 2 firms dominate a mission area, the government gains speed but loses options. The vendor becomes too important to fail, too important to alienate, and too important to replace quickly. This can give the firm leverage in pricing, access, terms, technical direction, and crisis behavior. It can also give adversaries a clearer target set. A concentrated commercial architecture may be resilient at the satellite layer while fragile at the vendor layer. That distinction matters. A constellation can have many satellites and still belong to one corporate decision chain, one software environment, one ground architecture, one update process, and one legal department. Many satellites do not automatically mean many sources of strategic control. The second layer is opacity. Defense customers often lack full visibility into commercial supply chains. They may not know which components are foreign sourced, which subcontractors support critical systems, which software libraries are embedded, which cloud services process data, or which overseas facilities support operations. Some of that information is proprietary. Some of it is messy. Some of it may not be fully known even by the prime vendor, because modern supply chains have the manners of a spider web in a windstorm. Entropy is manageable in peacetime. It becomes dangerous in crisis. If a critical component comes from an adversary-aligned country, the government needs to know. If a supplier has poor cyber hygiene, the government needs to know. If a software dependency can be poisoned upstream, the government needs to know. If a ground station sits inside a jurisdiction vulnerable to political pressure, the government needs to know. This does not mean every commercial provider must be treated with suspicion. It means trust must be engineered. Vibes are for coffee shops, not national security space. The third layer is misaligned incentives. The government wants wartime assurance. The company wants revenue, growth, survival, reputation, investor confidence, legal safety, customer retention, and technical viability. These goals can overlap. They can also collide. Suppose the government wants priority access during crisis. The company may have existing civil or commercial contracts. Suppose the military wants rapid modification of a service. The company may need engineering time already assigned to other customers. Suppose the military wants a provider to operate in a contested zone. The provider may face insurance, legal, escalation, and personnel safety concerns. The answer is not to scold industry for being industry. A company that ignores business reality will soon provide the government with a fascinating new capability called bankruptcy. The answer is to align incentives early. Contracts should define priority, surge, cyber standards, continuity, reporting, data rights, and crisis support. They should account for the cost of resilience. If the government wants wartime behavior, it must pay for wartime preparation. The fourth layer is integration before crisis. Commercial space cannot be treated as a glass box opened only when government systems fail. If the joint force plans to rely on commercial services during war, those services must be integrated during exercises, tested under stress, connected to operational workflows, and evaluated against adversary action. The worst time to learn the details of a vendor interface is during a crisis. That is the defense equivalent of reading the parachute manual after leaving the aircraft. Integration means operators know how the service works. Security teams know the cyber boundary. Lawyers know the authorities. Contracting officers know the terms. Commanders know the assumptions. Industry knows the mission context. The whole arrangement has been exercised, broken, repaired, and exercised again. That is what turns commercial dependency into commercial resilience. Let's put this inside a scenario. A regional crisis escalates. The joint force needs persistent coverage across a broad maritime operating area. Military satellites are tasked heavily. Adversary counterspace activity increases. Jamming appears in several bands. Cyber probes hit ground networks. Weather complicates collection. The commander needs commercial imagery, commercial SATCOM, commercial analytics, and rapid launch options for replenishment or augmentation. On paper, the United States has access to a powerful commercial space sector. In practice, the staff has to answer hard questions quickly. Which commercial imagery providers can support the operating area? Which have collection access? Which can deliver data into military systems? Which products are approved for classification handling? Which providers can withstand cyber pressure? Which have foreign ground stations? Which customers receive priority? Which contracts already cover crisis surge? Which firms have personnel cleared for deeper coordination? Which launch providers can support the timeline? Which payloads are ready? Which components are delayed? Which range slots exist? Which allied permissions are needed? This is the moment when commercial space either looks like a strategic reservoir or a beautiful drawer full of mismatched cables. The difference is preparation. If the government mapped the vendor base early, it knows which providers support which missions. If contracts included crisis clauses, priority is clearer. If data paths were integrated during exercises, operators are not inventing procedures under pressure. If cyber teams tested interfaces before conflict, the attack surface is understood. If supply chain reviews identified fragile components, replenishment plans are more realistic. If multiple vendors exist, the force has options. If none of that happened, the commander may still have commercial capability, but every request becomes a negotiation, a technical discovery process, a security review, and a prayer arranged in acquisition language. This is why commercial integration cannot be treated as procurement convenience. It is operational design. The joint force should know which commercial capabilities are supplementary, which are essential, and which are mission critical during conflict. Those categories cannot be discovered after the shooting starts. By then, everyone is busy, the lawyers are popular for the wrong reasons, and the cyber team has that expression that makes commanders nervous. Commercial space also changes adversary targeting. If the United States relies on commercial providers, adversaries will study those providers. They will map corporate relationships, supply chains, ground stations, cloud platforms, key executives, launch sites, customer dependencies, and regulatory exposure. They will look for ways to coerce, disrupt, delay, embarrass, or divide. This targeting may stay below the threshold of open attack. An adversary may use cyber intrusion against a vendor. It may pressure foreign regulators. It may target suppliers. It may manipulate information about the company's role in conflict. It may create legal ambiguity. It may jam service in a narrow region, then deny responsibility. It may attempt to poison data pipelines. It may exploit open-source details about terminals, ground sites, or orbital patterns. In other words, commercial space providers become part of the conflict environment even when they are not combatants in the traditional sense. That creates a policy problem. The United States wants to use commercial capacity without turning every provider into a direct extension of the military. It wants the benefits of a private space economy while protecting companies from coercion and attack. It wants resilience through commercial scale, but adversaries may see commercial systems as softer targets than military systems. The legal and strategic boundaries will be contested. That is unavoidable. The practical question is whether the U.S. government prepares companies for this pressure. Do they receive threat intelligence? Do they participate in exercises? Do they have reporting channels? Do they know how to coordinate under attack? Do contracts cover defensive measures? Do agencies understand what commercial providers can and cannot do during conflict? Commercial firms should not be left to improvise wartime coordination while adversaries are already inside the wires. That would be unfair to industry and foolish for national security. There is a cyber lesson here. A supply chain is not only physical, it is also digital. A space company may build satellites and sell data, but its capability depends on software repositories, developer tools, identity systems, cloud services, firmware, update pipelines, telemetry processing, encryption, monitoring, and customer portals. Compromise those layers, and the satellite may remain healthy while the service becomes untrustworthy. That is the nightmare. The asset works, but confidence in the output fails. A corrupted analytics pipeline can mislead decision makers. A compromised software update can degrade terminals. An identity breach can expose customer data. A cloud misconfiguration can leak operational patterns. A poison dependency can sit quietly until activated. This is the loading dock of the digital supply chain, and the locks are often less impressive than the front entrance. For national security use, commercial providers need stronger cyber baselines than ordinary commercial service. They need secure development practices, monitoring, incident reporting, access controls, tested recovery plans, insider threat awareness, and coordination with government cyber defenders where appropriate. Again, this costs money. Resilience is not free, neither is trust. The bill arrives either before crisis as preparation or during crisis as panic. Panic usually charges interest. Now let's talk about the defense customer. The Pentagon often says it wants commercial speed. That is good. But speed cannot mean skipping the hard questions. Fast procurement of a fragile dependency is not agility. It is paperwork wearing running shoes. Defense leaders should ask one practical question about every commercial space service. What would have to fail for this capability to vanish when we need it most? That question opens the real analysis. If the answer is one supplier, find it. If the answer is one launch provider, understand the backup. If the answer is one ground station network, map the jurisdictions. If the answer is one cloud provider, inspect the security architecture. If the answer is one corporate decision chain, establish crisis terms. If the answer is one software pipeline, test it. If the answer is unknown, do not confuse ignorance with resilience. The goal is not perfect independence. Perfect independence is expensive, slow, and often imaginary. The goal is intelligent dependence. That means the government knows where it depends on commercial providers, why it depends on them, how those dependencies behave under stress, and what alternatives exist when something breaks. It also means avoiding a lazy division between government and commercial. Future space architectures will mix both. Government systems may provide protected, sovereign, highly assured capability for the hardest missions. Commercial systems may provide scale, refresh, capacity, and redundancy. Allied systems may provide geography, access, and political depth. The architecture becomes stronger when each layer is understood for what it can bear. Commercial firms should be invited into exercises before crisis. They should sit in realistic scenarios where communications degrade, adversaries jam, cyber alerts fire, launch schedules slip, and legal questions appear at precisely the worst hour, as legal questions are known to do. That is how both sides learn. The government learns what the vendor can actually deliver. The vendor learns what the mission actually requires. The contract stops being a ceremonial object and becomes a working relationship. For commercial space companies, the message is direct. If you want to support national security, build for trust before the government asks. Know your suppliers, secure your software, document your data flows, understand export controls, prepare incident response channels, know which parts of your architecture are foreign exposed, know how you would operate under cyber attack, jamming, sanctions pressure, surge demand, or public controversy. A vendor that can answer those questions becomes more credible. A vendor that cannot answer them may still have a good product, but it is asking the government to buy uncertainty. Companies should also be honest about limits. If a service cannot support certain operating areas, say so. If surge capacity requires funding, say so. If priority access conflicts with existing contracts, say so. If a system has dependencies that cannot be quickly replaced, say so. The national security customer can work with known limits. Unknown limits become operational traps. There is a temptation in commercial space to sell confidence. That is understandable. Investors like confidence. Customers like confidence. Conferences are built from confidence, coffee, and badge lanyards. But defense customers need more than confidence. They need accountable performance under stress. The companies that thrive in this environment will combine speed with seriousness. They will still move fast, but they will not treat security, supply chain mapping, and continuity planning as decorative paperwork. They will understand that national security is not merely another market vertical. It comes with adversaries. For policymakers, the challenge is balance. Regulate too heavily, and the government strangles the commercial sector it wants to use. Regulate too lightly, and the government builds military dependency on systems whose risk it does not understand. The answer is neither worship of the market nor nostalgia for government monopoly. Policy should define standards for mission-critical commercial space services. That includes cyber baselines, supply chain disclosure where appropriate, crisis support terms, data protection rules, foreign ownership review, export control clarity, and incident reporting. It should also create smoother pathways for companies that meet those standards to work with defense customers. The government should not demand that every small space company become a defense prime overnight. That would be absurd, like asking a violin maker to run a shipyard, because both involve strings in some poetic sense. The government should tier requirements according to mission risk. A company providing non-sensitive weather data does not need the same regime as a company supporting missile warning data transport. Risk-based policy is the practical path. The larger strategic picture is this. Commercial space can add resilience if it increases the number of pathways available to the joint force. It can reduce resilience if it replaces a few exquisite government systems with a few exquisite commercial dependencies. Proliferation by itself is not enough. Many satellites can still mean one vendor. Many vendors can still mean one supplier. Many suppliers can still mean one foreign bottleneck. Many ground sites can still mean one software architecture. The surface may look varied while the route remains narrow. That is why architecture matters. A resilient commercial space strategy should seek varied providers, varied orbital regimes where appropriate, varied ground paths, varied launch options, varied data processing routes, and varied contractual models. But this cannot become a ritual chant where the word varied solves everything. Specificity matters. For satellite communications, resilience may require multiple providers, protected waveforms, anti-jam techniques, terminal discipline, cyber monitoring, and realistic bandwidth allocation plans. For imagery, it may require multiple phenomenologies, different revisit patterns, clear data rights, assured tasking priority, and secure delivery paths. For launch, it may require more pads, responsive payload processing, spare capacity, range improvements, and pre-planned replenishment payloads. For data analytics, it may require source traceability, model validation, cyber controls, and human review. Every mission area has its own dependency map. The great mistake would be to describe commercial space as one thing. It is not. It is launch, communications, sensing, analytics, data transport, ground infrastructure, software, manufacturing, logistics, and finance. Each part carries a different risk profile. Treating all of it as commercial is like calling a ship, a dock, a map, and a sailor wet things, and then claiming you have a naval strategy. The military needs sharper language. Which commercial service is being used? Which mission does it support? How critical is it? What is the fallback? What is the cyber exposure? What is the supply chain exposure? Who owns the data? Who can deny access? Who decides during crisis? What happens if the vendor is attacked? What happens if the vendor refuses a task? What happens if the vendor cannot scale? These questions are not hostile to industry. They are the foundation of serious partnership. A serious partner can answer them. A serious government customer will ask them. There is also a cultural issue inside defense. Commercial firms often move faster because they accept more risk. Defense organizations move slower because they carry public responsibility, mission assurance, legal duties, classification burdens, and consequences that cannot be written off as business failure. Both cultures have their reasons. Both cultures can irritate each other into a small weather system of mutual contempt. The commercial side may see the Pentagon as slow, suspicious, and addicted to procedure. The government side may see industry as overconfident, undersecured, and fluent in promises. Both may be correct often enough to be annoying. Good integration requires translation. Defense leaders must explain mission needs in a way industry can build toward. Industry must explain technical and business limits in a way operators can plan around. Contracting officers must structure relationships that reward resilience rather than the cheapest compliant answer. Security teams must protect sensitive data without turning every interface into a locked chapel of paperwork. This is hard. But it is easier before crisis than during war. The war in Ukraine gave the world a preview of commercial space relevance. Commercial satellite communications, commercial imagery, and open source analytics all became part of the conflict environment. That does not mean every lesson transfers cleanly to a US great power conflict. It does mean the boundary between civil, commercial, and military space has already blurred in practice. Future adversaries will not politely respect procurement categories. If a commercial space service supports military operations, It may be surveilled, jammed, hacked, coerced, sued, propagandized against, or physically threatened. The provider's legal status will matter. So will the adversary's targeting calculus. So will U.S. response options. This is why commercial integration is also deterrence work. An adversary should see that U.S. space power has depth. If one provider is disrupted, others can carry load. If one ground path is attacked, data can move elsewhere. If one launch manifest slips, another option exists. If one data source is degraded, another source can corroborate. If one company faces coercion, the government can support it and shift operations. Resilience complicates enemy planning. Dependency simplifies it. That is the strategic test. So what should leaders actually do? Defense leaders should begin with dependency mapping. Take every commercial space service tied to an operational mission and map its chain. Satellites, ground stations, cloud services, subcontractors, key components, data flows, software dependencies, launch needs, personnel requirements, customer priority rules, and foreign exposure. This should not be a one-time paperwork hunt. It should be maintained as the service changes. Then tier the services by mission criticality. Some commercial products are helpful but replaceable. Some are important but can be substituted. Some may become essential during crisis. Each tier should carry different security requirements, contractual terms, exercise participation, and continuity expectations. Treating everything the same produces either underprotection or paralysis. Next, write crisis behavior into contracts. Priority access, surge capacity, incident reporting, cyber cooperation, data rights, termination limits, support under attack, and continuity expectations should be addressed before crisis. The contract should say what happens when the weather gets geopolitical. Then exercise with the vendors. Use realistic scenarios, degrade links, simulate cyber incidents, introduce legal ambiguity, force tasking conflicts, stress delivery timelines, see where the process breaks. The point is not to embarrass companies. The point is to find the weak seam while the price of discovery is still manageable. Finally, build alternatives. Do not let one provider become the entire plan unless the mission and risk justify it. Alternatives may include other vendors, government systems, allied systems, terrestrial backups, pre-positioned terminals, alternate data paths, or operational tactics that reduce dependence on any one service. For commercial firms, the mirror image applies. Know your own dependency map. Build security into product design. Prepare for government scrutiny. Be clear about limits. Offer realistic continuity options. Participate in exercises with humility. National security customers can forgive constraints. They are less forgiving when a constraint appears at the worst possible moment wearing a surprise hat. For policymakers, create the rules of the road. Clarify what counts as mission-critical commercial space support. Fund resilience, not only service purchase. Support domestic and allied supply chains for critical components. Build reporting channels for threats to commercial providers. Give companies a clearer path to share incident data with government. Avoid turning small firms into paperwork sacrifices. The goal is a healthier national security space economy, not a regulatory hay bale thrown into every corridor. Here is the forecast. Commercial space will become more embedded in national security operations. That direction is already set. The joint force needs scale, coverage, speed, and refresh rates that traditional government acquisition cannot always provide on its own. The commercial sector has too much capability to ignore. The hard question is whether the United States can use that capability without sleepwalking into dependency. Watch the budget. Watch how much funding moves toward commercial satellite communications, commercial remote sensing, data analytics, launch services, and commercial space domain awareness. Watch whether those purchases remain scattered across program offices or become part of a coherent architecture. Watch the contracts. Look for priority access clauses, cyber requirements, surge terms, data rights language, and continuity obligations. Those details will tell you whether commercial space is being treated as convenience or operational infrastructure. Watch the exercises. If commercial providers are present in realistic wartime scenarios, that is a good sign. If they remain outside the real planning process until crisis, the trap is still open. Watch the supply chain reviews. Serious integration will require visibility into components, software, ground infrastructure, and foreign exposure. Nobody needs perfection. They need fewer surprises. Watch adversary behavior. If commercial space providers become targets of cyber campaigns, regulatory pressure, influence operations, or jamming, that means adversaries understand the dependency map. The United States should understand it first. Commercial space is one of America's great advantages. It reflects a national habit that remains powerful. Build, test, launch, sell, revise, and try again before the committee finishes renaming itself. That energy has strategic value. But national power cannot rest on energy alone. It needs structure. It needs discipline. It needs boring files with accurate supplier names. It needs contracts written by people who understand that crisis has no respect for vague language. It needs commanders who ask where the service comes from, what can break, who decides under pressure, and how fast the force can route around failure. Commercial space can give the joint force reach. It can give the force scale. It can give the force tempo. But it can also give the force hidden dependencies wrapped in elegant dashboards and optimistic delivery dates. That is the line to watch. The future of national security space will be neither purely government nor purely commercial. It will be a braided architecture of state systems, private systems, allied systems, and software-defined services moving through contested networks and contested orbits. A braid is strong when the strands are known and tension is managed. A braid fails when everyone admires the pattern and nobody checks the fraying. The vendor dependency trap begins with a comforting sentence. We can buy that from industry. The strategic question comes next. Can we still count on it when the war begins?